Good evening, everybody, and welcome back to another great vBrownBag. Tonight we have Kenny Garreau coming back, and he's going to be talking about Docker Swarm in part two of his Docker deep dive. As always, we love to have the live audience interact with us and people on Twitter. You can tweet at us at vBrownBag. And I'm going to be following the hashtag vBrownBag and will ask any questions or make any comments that I get off of Twitter and have Kenny answer them. If you want to join any of our other shows, you can follow our schedule with the Europe, Latin America, and US shows. And without any further ado, I'll hand it over to Kenny. Kenny, how are you doing tonight?
Good, Tom. Thanks for setting us all up. So, hopefully be able to fill you guys in a little bit about what we did last week. So I want to do like a really brief review because we got some really great questions after the pod. And if you wanna go ahead and make me presenter, I'll go ahead and show my screen here. So can you guys see my slides here?
Yep, sure can.
Okay, great. So, so I'm Kenny Garreau. I'm a technical solutions architect. I work at AppDynamics. I'm a VMware certified design expert, and I got really interested in Docker because it's kind of the next layer and next level of virtualization. So, we did a 101 session last week, which was kind of to pique everybody's interest. If they're interested in containers and particularly Docker. We got some really great questions. So I'd encourage you to watch that pod to get up to speed if you haven't already. I don't know if it's posted yet, actually. If it's posted, have a gander. Some of the stuff we covered in that pod will be kind of a review this week. But hopefully, if there's any questions, about anything you saw last week or as we're going along, hey, I don't understand this, feel free to use the questions box or, shout out to us on Twitter. So,
Kenny, real quick, it is posted. It was posted yesterday.
Oh, great. So hopefully people had a chance to watch it. If not, then, feel free to, give a shout out. Yeah. Keaton had asked to see if we could send out the link for the session in the questions. So hopefully I didn't butcher your name either, man. Again, after the pod last week, we had some really great questions around not just the infrastructure side of things with Docker, but philosophically and kind of from a developer standpoint, like why would I be interested in doing containers? Where is a developer coming from when they want to look at containerization of their applications? So I'd given 2 links last week, and I said that I would give them this week as well. So if folks want to copy these links down, we're also going to put these somewhere either on the vBrownBag website, or we can put them in the in the questions panel here. But the first link deals with microservices architecture. And one of the things that we talked about was the fact that, microservices and Docker are not mutually exclusive, right? So if I'm running Docker, it doesn't mean I'm doing microservices. And if I'm doing microservices, it doesn't mean I'm doing Docker. So I think that the architecture module that's out on Pluralsight was really great because it really highlighted that hey, this is more of a design philosophy with regard to code and how I consume code, as opposed to using a product to drive a specific technology. The second link that I provided was around clean architecture. Really, it's focused on, hey, why should I code things this way? Why should I build things this way? Why should I deploy in a microservices architecture? What's the difference between microservices and a monolithic architecture? It was a really good comparison and contrast of different deployment methodologies and design principles. So again, you don't have to be a coding master to watch these and to kind of understand what they're doing and what they're trying to make sense of there. So With that, we'll jump into Swarm. So let's talk about the audience again. If you're a DevOps guy and you're just shooting through code, probably my presentation is going to be a little bit beneath you. So we're really targeting this at infrastructure folks, virtualization gurus, and then just tech generalists. Hey, I want to learn something about a new technology. Maybe we can teach you something here. So we'll talk about building on the foundational level knowledge that we had from last week. I know I showed some stuff in the demonstrations last week around kind of the differences between containers and services. We're going to go a little bit deeper on that today to hopefully bring out some, tease out a little bit more understanding around that. We'll talk about clustering. Swarm is the technology in Docker Engine for clustering. So that's really what we're talking about here. Again, talk containers versus services, and then show you, kind of some of the cool features. That you're going to be able to do on the command line, but then B, you'll be, in a larger environment, you'll be doing this from some sort of orchestration platform. So let's just talk about some of the goals when we're building clusters. Doesn't matter whether I'm building an application level cluster, whether I'm building a hypervisor layer cluster, or whether I'm going to that container level of clustering. Generally, what we want to do is provide access to homogeneous resources, so storage, compute, security. There's probably a list of 10 of the things that I could think of as far as resources, but generally it's A, infrastructure, and then B, some sort of logical type of access. We want to manage availability and our fault tolerance for our workloads. So generally, the engine that we are going to use is going to provide a lot of that for us. So when we're thinking about vSphere, we're thinking about things like HA and DRS. HA handles a lot of my availability and fault tolerance, and the DRS is responsible for scheduling, which is what we're talking about here in terms of conducting workload scheduling. The major difference here is that when we're talking about Docker scheduling, we're talking about scheduling the containers, right? So we're talking about scheduling an application as opposed to scheduling within DRS, which is going to say, I want to schedule a virtual machine. Another kind of, it's not necessarily a goal, but kind of a characteristic of clustering is that if I'm performing maintenance operations, I want to minimize or eliminate downtime. Now, when I say minimize down, there's always going to be some sort of downtime involved in the process when you are doing maintenance, right? So like, all of my systems together can't be up 100% of the time. Eventually, I'm going to need to patch vSphere or patch my Docker hosts or whatever happens to be. So those are going to go down at some point. But the idea is the stuff that they're serving should not go down. And that's when we're talking about redoing workload scheduling in containers. And that's when we're talking about things like vMotion or, obviously HA or FT in vSphere. So just given the virtualization examples for a lot of us, just because, I think that that's, the audience that we're targeting here. So primarily, when we're going through this, to create a swarm, what I want to do is I want to get some nodes, and that's some of the terminology that we'll go through, I think, in the next slide. We're going to gather a bunch of Docker hosts. Now, those hosts could be bare metal. They could be virtual machines. They could be instances in Amazon. And that's the lab environment that I have is set up in Amazon. So the idea is that I want to gather a bunch of these and I want to create a swarm. So I want to create a cluster of these guys. So I run my Docker swarm init. I run a Docker swarm join on my peer nodes or my worker nodes that I have. And that's it. So I'm going to hop out here. And we're going to go ahead and, as long as you can see my SSH windows here, what we've got is, some Docker hosts in each of these tabs. They are Amazon instances running Ubuntu. Sudo Docker version. One thing you guys will get really familiar with is running sudo. Yeah, so we've got our Docker versions out here. So what were we saying? Sudo Docker swarm init. Okay, I just created my cluster. So cluster's been created. So what we see here is swarm is initialized. Here's my node ID. If I want to add a worker, I need to run this command. So what I'll do is I'll copy this command because I don't really want to type that guy out by hand. What will happen is when I go into my other nodes here, this node is joined as a worker. This node is now joined as a worker. So 3 Amazon instances, each running Ubuntu. I just created my cluster, with a few commands. Now again, you might have other platforms that are going to manage your clustering and stuff like that. So you might be using Mesos or Kubernetes or something like that to create your clusters for you. But obviously in these examples, we want to use the command line here. So the thing to remember about Docker is that we always have the -- help context, and we always have kind of just that capability of doing, obviously tab complete, but typing out my commands, and if it's not complete, it's going to list out what my options end up being. So you see here in the Docker Swarm commands, I have a join token. The join token can specify whether I want to join other workers to this, which is very important because not all of us are going to write this big long string down. But the point here is that, hey, look, I always have access to these commands to come in here and figure out how I want to manage the swarm. So actually go back here. Let's Docker node. There's some specific commands that get run or that you'll have to run that are, for swarm operations only, right? So like the Docker node command, the Docker services command, obviously the Docker swarm command, those are going to be for managing entities that are managed by a swarm. So what we see here in the Docker node ls command is showing me the nodes that are a member of this swarm. Now I can size the swarm up, I can size it down. There's some best practices that I'll see if I can dig up by the end of the presentation, or maybe while we're taking Q&A later, that discuss how do we want to size these swarms from a generic sizing, meaning I want to have 20 nodes in here, and then also from a manager sizing. So how many managers should I distribute throughout my cluster to make sure that I have maximum availability and fault tolerance and things like that. And it's not a case of more is better. Typically the swarms function pretty well when you're in that 3 or 5 manager distribution. So we'll pop back in here. So again, if you're following along at home, again, these are the only 2 commands that you have to run. You can dynamically remove nodes from a swarm. Generally what you want to do is you want to make sure that, hey, I don't have workloads that rely on local resources or anything like that. But we'll kind of get to some of that stuff when we talk about some of the features that you have when you're running swarm. So I'll go through some swarm lingo real quick, just so that we can all talk the same language when we're done here. So again, the swarm is a cluster. The cluster is made up of Docker engines. The Docker engines are referred to as nodes. And now again, I have 2 types of nodes. The manager node, the managers are responsible for scheduling and orchestration. So telling the other nodes telling the worker bees what they have to do. The workers are responsible for executing the commands that they receive from the managers. The managers are generally going to pass along a few tidbits of information. They're going to say, here's the image you need to run. Here is the scheduling algorithm you need to use. Here are the tasks that you need to run along with that. So arguments or commands or anything like that, they're going to be associated with running that service. And again, these aren't mutually exclusive. If I make a node a manager, he's still a worker. There's ways to restrict so that I could say I only want managers doing manager functions. But generally what we see, kind of deployed in the wild is, unless you've got a really, really big cluster, generally it's pretty efficient to have, nodes be doing both, dual duty. Services. So again, last week, I think we talked a little bit about the difference between containers and services. A service, yes, it runs a container, but it also assigns a task, and obviously it takes some sort of arguments as far as what that service is supposed to accomplish. And we'll kind of outline that in the upcoming slides here. Generally, it's for stuff like, how do I want to schedule this? How many replicas do I want? How do I want to run that container? You know, do I want to distribute it in a replicated fashion versus, say, a global fashion? Those are things that we'll kind of get through here. And then tasks, you know, the task that is being executed by the worker. Again, it's the commands that I need to use to instantiate that container, and then obviously the image that I need to run. So again, that's the thing here, is that the task's responsible for a few things, right? It's responsible for making sure that image is there, making sure any resources that the container needs are present. So it's really important to understand the distinction between a service and a container by itself. So we're going through the services process. Generally, when you're going to run a service, you know, a distributed service, what you want to do is, you know, again, if you're going to manage this through a centralized orchestration platform, obviously this applies in kind of a different fashion. But generally, we're going to do a few things. One, we want to define a name for the service. So I think that the thing that we've gone through last week is that we said, hey, look, you know, I'll just bomb out here for a second. We see that when we want to say sudo docker run, let's see, Alpine ping. What's our container doing here? We do a Docker run, so we pull down the latest Alpine version, and then our objective with this container is to ping google.com. So again, kind of a single thing that we're doing here, and that's what we want to. That's the beauty of containers, right? We want to do one thing and we want to do it well. When I stop that ping, my container stops running. If I want to run that in a detached mode, which is one of our Docker run flags, then I obviously have the capability of doing that. But I wanted to show you kind of, guys, what we're doing here in terms of running this. So Docker run. So again, Docker run, we're going to run this detached. We are going to run the Alpine image, and the Alpine image is going to ping google.com. So what we see here is that has been scheduled. So if I do a Docker container, I can see that the name here, Quizzical Dijkstra. Probably not going to remember that. Probably not going to remember the context of what that guy was doing. But if I was to run that image and call it, you know, Alpine Pinger, Alpine Ping Google.com. Now I can see that, hey, look, I named it Alpine Pinger, so I know that Alpine Pinger is something I created, and I know what it's doing, right? I've got some sort of description. So if we come back in here, that's what we're really wanting to do. You know, you don't have to. It is not mandatory. You could just run a service just like you could run a container, like we did in the previous example of running that, let it assign its own name. But for sanity, let's just say that we're gonna create a name for ourselves. After that, typically we want to have, you know, the idea behind a service is that, sure, I can run a container as a service, right? So I could run it with a single replica. And that's typically a recommended deployment methodology when I want to take advantage some of the scheduling and placement that I have with services, but I want to get away from running it as a single container. Because again, container management is by individual Docker host. Service is cluster wide. After that, I'll attach it to a network. I'll select a container image, and then I feed any arguments. So again, in our example that we just had, sorry, I'm trying to get the GoToMeeting stuff out of the way. In the example that we had before, we were running the Alpine container. We pinged google.com instead of 8.8.8, but you know, same thing, I guess. And then, you know, we made sure that we attach it to an overlay. And then, you know, some of the stuff that we had talked about previously was where do things get attached by default when I run containers. That's some of the stuff that we reviewed last week. So while this contain, you know, the service that we started, the container we started, didn't get attached to that overlay, and the examples going forward, we'll see if we can attach to that overlay. So again, really the only thing that is required out of this Docker service create command is the image, right? Because Docker can take care of telling, hey, look, here's how many, obviously the default will be to have one replica, but it'll attach it to a default network, which is our bridge network. It will run the image. It'll pull the image if it needs to. And then, Alpine's a distribution of Linux, so it might just set up a bash shell and that'll be that. But instead, we're feeding it some arguments here. We're saying we're going to ping this. I'm going to say I want 3 copies of it, and I'm going to say that it's going to be attached to this specific network. And those are things that you should get used to, right? You should get used to either designing your applications or talking to your application admins about, hey, how many replicas of this are we going to have out there? How are we going to front end this? What networks are we going to connect to? Now, those are things that the app guys are probably not going to care about what network they connect to, but they're definitely going to care about the availability of the application. Because when you get towards that DevOps model and people being responsible for code from inception to death, I can tell you that they don't want to be called on Saturday because somebody started up with no replicas and you had a maintenance or an outage. So I'll talk about some Swarm service features and kind of commands that correspond with those. Now, certainly these are not all of them, right? If you go on to docs.docker.com, if you go onto the command line and you run a sudo docker service create or a service update, there are quite a few options beyond what we have here, but I'm kind of highlighting some of them to kind of, wet our whistle as far as things that, hey, look, in the virtual world, I used to, attach a VMDK, or I used to, attach a raw device map, or I had to create a VMDK on a data store, things like that. These are things that I want to make sure that we understand. So mounting a volume. So you remember last week we talked about volumes and the fact that volumes are a good way to get data persistence within my application layers. So in a volume, I might put stuff like stuff that is not necessarily transient, right? So I might have a database in a volume, or I might have application data in a volume, or I might have some sort of distribution sensitive stuff in that volume for my application. And there's some other features that we get to in terms of configs and secrets, which we'll get to. But for now, let's just talk about volumes. So again, when I want to keep data somewhere and I want to present it to a service, so if I've got 10 web servers that I need to make sure that they all have the corresponding, ASP pages or HTML pages or whatever it is that I've developed, I can use a volume to make sure that everybody has access to those. I can use the placement preference command to specify how and where I want to place my workloads. I can scale my applications on demand. So in the previous example, we created 3 replicas. In this example, we're going to create 4. I can use the update command to say, hey, look, you know what? We're going to release a new version of the website, or we're going to release a new promotion, and we're expecting, 3x the traffic. Okay, I can scale up that service just by using the Docker service update command. So what will happen is if I say, hey, look, I've got 4 replicas now and I want 12, I use the Docker service update command to change the amount of running containers that I have from 4 to 12. That's one of the examples that we'll go through on the command line. I can reserve CPU and memory. So this might be helpful in instances where I may be getting like out of memory errors, or I want to make sure that I've got that slice specifically reserved. So obviously anybody that's done anything with resource pools and vSphere is probably really familiar with that. The cool thing is not only can I create a service one way, but most of the commands and flags that are available for creation time are also available to update that image. So if I say, hey, that volume that you mounted in all these containers that are out there, yeah, no, we need to change that volume. We moved the source, or we moved our our page code from this NFS volume to this other NFS volume. So I can use the Docker service update command to change the location in my containers dynamically. I can also update those images, right? So images work on the idea of tags, right? The tags tell me what version of an application it is that I'm running, right? So, let's say I'm running in Nginx 1.13.1 in a previous version. And then I want to update my images that are running out there to 1.13.3. The Docker service update command, basically, if I feed it that image flag, it says, hey, any of the guys that are running with that Nginx 1.13.1 are going to be updated to 1.13.3. Now, obviously, there's arguments you need to feed in here, right? You need to tell it what service you're updating. You can't just say, oh, Docker, update everything. You have to specify the service that you want to update. And that's one of the flags that we're missing here. But again, I didn't want to burden the screen with, -- name and all of the other arguments that are in there. So again, I would encourage you guys either to look at the docs.docker.com repository for, just kind of the standard RTFM, which there's going to be a link later in the presentation, or just get your hands dirty on the command line. It's really hard to break this stuff. And when you do break it, it's actually really easy to fix it. So it's one of those things that is really cool about Docker. So we'll talk about replicated services and we'll talk about global services. And so I think that kind of an illustration really helps here. So a replica service says, I want to schedule the container according to whatever placement algorithm I end up using, placement schedule I use, on any node that satisfies those requirements. So, hey, look, as long as I've got the resources, if I say, hey, look, I need a node where I can reserve, 1.5 gigs of memory for this container, then if there's a node that can't satisfy that requirement, it doesn't get scheduled on that node. What that will mean is that, hey, if I've got, so let's take that as an example. Let's say I create 3 Docker nodes. One's got, 16 gigs of memory, one's got 32 gigs of memory, and one's got 1 gig of memory. If I say I need to run a container and reserve 2 gigs of memory, obviously that third node isn't going to get a workload scheduled on it, right? Because I've said, hey, look, the qualification for running this is that I need to be able to have 2 gigs available to me. So it might just get scheduled on the first 2 nodes. And then if I schedule more workloads, those will get scheduled on those nodes as well, until I either change the resource requirements to be able to be sent onto that node, or until I add other nodes into the cluster that are capable of running those. So you can see here, I've said, hey, look, in a replicated fashion, if I'm running node, I might go onto worker A and worker B, and then if I did, run a Mongo container, it might be put onto worker C. So pretty straightforward as far as how we schedule things. In a global service, it functions a little bit differently, right? A global service says, I want a one-to-one relationship between any of the applications, containers that I'm running, and my worker nodes. So, a reason that you might do that might be that, you want to absolutely ensure that a specific service is running on every single one of your, worker nodes. So if you had, I don't know, like an agent that was containerized, and you wanted to make sure that, hey, look, this agent is containerized, needs to be deployed on every single worker that's out there, a global service might be a reason that you would end up doing that. There's other examples here, right? If you said, hey, look, I'm going to deploy a miniature firewall, or I want a load balancer on each of these guys to participate in a load balancing cluster, like those are the reasons why you would end up doing that. Just pausing here to get a drink. So let's just do a reset on containers and services. The considerations that I have to take into account, again, the illustration that we have on the right-hand side here, when I've got a container, the container is the guy on the left-hand side here. I've got an image. That could be Node, it could be HTTPD, it could be Ubuntu or BusyBox or whatever it is. That image gets spawned into a container, and that container is then provisioned on that host you're connected to. So again, in our example that we have here, these containers that are listed out here, those guys are local to this specific node, this specific Docker engine. So that container container ID 6997, blah, 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 blah. That guy is available here. He's not available anywhere else on the cluster. So even though this guy is in a Swarm cluster, I still have the capability of scheduling containers locally. In a service, again, so what we're doing is same thing. We've still got an image. I don't use a different image for node. Node's a bad example because we're using nodes as double terminology here. So Ubuntu, let's say. So if Ubuntu is my image, when I want to run Ubuntu as an image and as a container in my cluster, right, in my swarm, the image is, again, I use a task to spawn that image. The task is responsible for creating the image, pulling that image, creating the container, feeding any of that specific local information up to the service and quiescing it in Raft, and then provisioning it on a worker. So there's different steps in the chain that get accomplished here that I don't necessarily have to think too much about, right? When I'm running a container, I have to think about the host that I'm running it on. If I'm running a service, I don't really have to do that because the cluster is responsible for keeping track of where those guys are, who has the appropriate resources, things like that. So again, kind of the considerations on the left-hand side here is to consider, how do I want to schedule this? So if I've just got, a single Docker host or a single VM for testing, I probably don't need to, get Swarm going or anything like that. If it's only being used for really small scopes of testing, I might not be concerned about it. I might just say, hey, look, I'm fine with just running a container. Or if I'm running it on my, on my MacBook or, on my desktop or whatever, I'm probably going to be just running, the straight Docker run command. I want to think about how I want to orchestrate it. So again, been doing testing, I could probably just do a Docker run, and that's probably all I need. But if I'm saying, hey, look, for our pre-production deployment, I want to consider, 7 replicas for this specific service, that's when you're going to start thinking about, how am I going to build this application? How am I going to provide availability? Things like that. That's kind of the things that we're talking about here. How do I manage multiple containers? How do I update them? That's one of the really big, powerful tools in the service update is that, hey, look, if there's a code vulnerability in this specific version of the application, I have the capability of upgrading that on the fly. And the Swarm takes care of reinstantiating those containers with all the right code, with all the right volumes, with all the right parameters that I feed to it on the fly. So those are kind of some of the design considerations that we need to think about when I say, hey, look, I'm okay with this running in a container versus, hey, look, I want to start to provision this as a service. Generally, what I tell folks is, you may want to start thinking about, a local Swarm environment, if you've run it on a MacBook or whatever, or, even in your local, data center, if you've got like a VM that's out there that's doing stuff. Just because, you may just say, hey, look, as part of my build process, I made sure that I deployed this guy as a service, and that there's not going to be any, issues that I run into down the road. One of the really cool features that we've got within Swarm is the capability to do native service load balancing. Let's just be clear, this does not replace your load balancers. It doesn't replace F5s, it doesn't replace NetScalers, it doesn't replace HA proxy. That is not the point of this. What the point is that when I build my cluster, so again, the Docker Swarm init and my Docker Swarm joins, you can see on the right-hand side here, I've got 3 nodes, right? Worker 1, Worker 2, Worker 3. There is a Swarm load balancing component that is present in any of these guys. So we'll get to what that means in a second. So I've done my Docker Swarm init. These guys are all part of a swarm. When I create a service after this, there's a few arguments that I'm feeding in here, right? So one, I'm going to call that service nginx. So maybe I will use a better name in the future. But just for illustrative purposes, we can see here that, on worker 1, my service 1 gets scheduled. Worker 2, service 2 gets scheduled. You can see what we're doing is the container itself is publishing port 80. We publish port 80 on port 7280 on the actual Docker node itself. So again, for those that aren't familiar with publishing and things like that, we're going to do a much deeper dive in 2 weeks on networking. But anybody that needs to kind of see what the example is, basically what we're doing here is we're saying, hey, look, my containers, the source is port 80, but I want to publish this as port 7280 to my load balancer. Now, I may or may not have a load balancer in front of this. So what I've done here is I've said, I want 2 replicas running the NGINX image. What the load balancing in the cluster ends up doing is now each worker, I forgot to make this worker 3 down here. Each worker has the ability to respond to a request on port 7280 for that service. So what we can see here is that 10.112.7280 is going to answer that request. It might feed the request to a local. It might feed the request to its secondary over here, this other replica that exists on the other worker. This is some of the stuff we'll get into in overlay networks and swarm networks and control plane and data plane and things like that. But what we want to illustrate here is this third node. The third node's the really important one where it starts to click, right? I don't have any containers running on here, but if I do happen to make a call to that IP address, the swarm knows, hey, I've got 2 containers that I can route that traffic to. So again, the swarm's keeping track of that state for connectivity to my containers. So what happens if I want to add a load balancer into the mix? Now what I might do is my VIP might be 10.1.1, and I might want to have this web service responding on port 80, right? Nobody needs to know that it's 7280, as kind of the intermediary here that's being load balanced between these workers, and that they're Docker images. And nobody needs to know that they're on this other network that's serving up port 80. So there's 2 translations that are happening here, right? We do one to 7280, we do another to port 80. But what I have the capability of doing here is providing a single VIP. And now when somebody goes to, kennyskickasapp.com, they're going to get load balanced between these 3 addresses. Now, HA proxy doesn't know that this worker down here doesn't contain a container or isn't running a container for that. So again, this goes to our discussion before about, hey, do I want to have NGINX be a replicated service, or do I want to have it be a global service? So again, just some considerations that you have to, think about when you're deploying, your containers and you're deploying your apps within your containers. So again, we go back here. This piece that you can see here is native within Swarm. I don't have to do anything. I don't have to change anything. But if I do want to have load balancing outside and I want to have a legit load balancer in front of it, so HA proxy is my example here, but again, this could be an F5, it could be a Citrix NetScaler, it could be whatever you have that you want to have sit in front of these guys. So again, 10.1.1.80, that's my VIP, and then my participating nodes are here. The participating nodes are not my containers, they're the workers. So just a pretty cool way to kind of to illustrate how we do things. There's a very similar diagram that's up on the Docker docs that's very similar to this. They do it better, but I didn't want to just coldly rip off their content. So kind of wanted to make it in a slideshow format. So pushing on here, and I want to jump onto the command line here in a minute so we can kind of go through some examples. But secrets and configs. Secrets and configs are newer entities to kind of the Swarm realm here. So we want to, what if I had a container, again, our previous example of NGINX, what if I've got a bunch of web servers that just need the same config options set? I might want to use Docker configs. The configs allow me to say, hey, look, you know what? Everybody gets this version of their .conf file. And then as part of my execution or runtime process, I might use set or awk or something like that to change a runtime, a specific configuration line within my comp file. That's the real applicability of using configs. Secrets. I'm a Hearthstone nerd. What if all the containers that I had in a service need the same SSL key? So where this comes, where this is valuable is SSL keys, private keys, passwords, things that are secure that maybe I don't want to put into a Docker config. There's a different process that ends up happening when I use a secret versus when I use a config option. So that's really important to kind of understand in the whole build process or the deployment process when I say, I'm distributing configuration files versus distributing a public key file, or not a public key, but a private key, or a password, or an SSL key or something like that. It's important to make sure that you distinguish between the two and the right scenario to use either one. Now, again, this just provides another way to kind of, cut the mustard, right? I can use Docker configs if I just need to put stuff in there. Docker volumes was a previous way that we ended up doing that. So you'll kind of get your choice of what you want to end up doing. Using configs ends up being a little bit more elegant in terms of the configuration stuff, because if I only need to provide access to 1 or 2 files, using an NFS mount through the Docker engine from however many engines that I have running to an NFS data store might be a little bit less efficient than just a straight Docker config. So hopefully that makes sense to you guys. But it's really a way for me to slipstream something into the image. Generally, I want that to be something small. I'm not going to use Docker config to push a database into a specific image. That's just not something that that you would want to do. So the getting started there is there, but like I want to jump on to the command line here and kind of give you guys some examples as far as what we can do with Swarm, and then how Swarm operates, and then how we can kind of update some of our running services. So if I do, don't forget sudo. If I do a sudo docker service ls, what we're doing here is we're saying, hey, look, tell me the services that I've created. So tell me the images that are out there that are running. Right now, we don't have anything that's running out there. So what I could do is I could say sudo docker service create. Now, one of the things that you'll notice that as we go through this, I'll kind of highlight. Let's just call this Alpine service pinger. And I'm going to say I want to run 4 copies of this. And I want to run the Alpine image. And on there, I want to ping, let's just keep it like the example that we had before, ping 8.8.8.8. So what this command is doing, creating a service, it's naming it Alpine service pinger. So when I do a docker service ls, hopefully it'll have a friendly name for me. I specify how many replicas I want. So how many copies of this image do I want to run on the cluster? Keep in mind, the cluster's keeping track of the state of that container. So what happens when one of these containers, if somebody happens to attach to that guy and runs a Control-C? Well, the container's going to exit, right? Because the container's function right now is this, pinging 8.8.8.8. I could also have it just run a bin bash or run the image itself or run a busybox or whatever it happens to be, and it'll just sit there, right? But I'm giving it a function. And when that function has ceased to exist, the container exits. So when the container exits, Docker says, or Swarm says, hey, this guy exited for some reason. He ran out of memory, ran out of disk space, whatever the circumstance ended up being. I'm responsible for figuring out what the state of that image is. The state of the image is run. So generally what you'll see is when we do that Docker service ls, if I see one drop off, the swarm is responsible for restarting that guy for me with any of the arguments that I provided, etc. So let's go ahead and create this guy. So again, you see here, since detach was not specified, the task will be created in the background. Now you remember, we scroll up here. When we did our Docker run and we ran ping google.com, it runs it to standard output, right? So right on my screen, that's what I see. In my next one, I specified that I want to run that as a detached image, meaning you're going to run this until I stop you. So that's what this service create ends up doing by default. So again, I don't have to specify, those specific commands or anything. The service command is just going to be responsible for that. So now, what we can see here is I've got a service ID. The service ID is, there's multiple ways to interact with either a container or a service. One is via the container ID. The other is via the name that I give that. So if I want to do something to Docker service update this guy. So what I'm doing here is I'm saying, hey, hey, you know what? I need another image out here. I need another copy that's running because I need more pings out to Google. If I do a Docker service ls now, we can see that on demand, we've scaled that service from 4 copies to 5 copies. And again, I used the ID of that to do that. Now, alternatively, I could run the same command and say --name alpine service pinger, and you know what? I really want to ping Google. Oh, wait a minute. What did I mess up here? I can't remember the flag there, but Docker service ls. Again, the kind of the point here is that you've got multiple ways to interact with either the service or the service ID. So it's really important that that's why I say it's always really important to understand what you've named the service. Now, if I want to find out what the service is actually doing, I give it this Docker inspect command. Now, unfortunately, it spits out everything in JSON, right? But what it's doing is it's telling me, hey, look, this is what this guy is doing, right? This is what type of what type of container it is. When did I run this? Things like that. And then obviously you can see what are the arguments that I've provided here. Obviously the arguments are ping 8.8.8. If I want to change anything as far as resources, placement, etc., those are things that I use the Docker service update command for. So if you run the -- help here, you'll see all the options that we get to provide if I want to update a specific service. So again, really just to illustrate here, if I say sudo docker, actually, I'm gonna make this a little bit bigger so you guys can see here, bigger. I'm not using a Mac keyboard. I know the Mac. I know the shortcuts. So don't hate. Service. You can't do that because he's not a manager. Forgot that. That's an important distinction, right? If my workers are not managers, the managers are the ones that are responsible for the command and control, right? So some of the stuff I might not have access to on those specific nodes. So really, I think the important thing here is to make sure that you understand the difference between a service Docker container ls and a container. So you can see here, oh man, all right, well, I've got containers that are running here, right? Well, Alpine service pinger, oh man, that sounds really familiar. Well, remember, the services are containers. And that's how I get access, and that's how I figure out which of those guys are running on here. So what we should see going into each of these guys, I forgot to update my fonts here, bigger, sudo docker container ls. So again, you can see, since we said, hey, look, we want this service to have 5 replicas, you can see that 2 of them are running on node 1, 2 of them are running on node 2, and 1's running here. And again, if I scale this guy up, chances are one of them is going to get scheduled here, right? But again, we want to know that, hey, look, if I don't have the resources to schedule the container and the service, you'll see some weird behavior in terms of this Docker service ls. So when you see a mode that doesn't say replicated, or if you see a mode, or if you see not the maximum amount of replicas here, so if I change the replicas to like 200, eventually I'm probably going to run out of memory to put these guys on these instances, because Amazon, they're what, 1 gig, 1 vCPU. So that's the other thing to kind of make sure that we keep track of, and that's one of the things that we talked about in the previous session. Right, was, hey, if I've got Docker hosts here, I have to make sure that I can manage these guys effectively, and that's when we talked about stuff like Mesos and Kubernetes and things like that. So it's all going to depend on what your goals are as far as a management platform. But if you go and you Google, if you Google container management, you're going to find a lot of stuff out there. So there's a lot of products that are at market. Docker has their own stuff. Obviously, Apache and Google and all those guys, they've got their own management platforms as well. So I'll come back in here real quick. So again, I had this on the previous session. How do I get started? Again, all these guys, the stuff that we've done in the demo here has all been in EC2, and it's all been done using the free tier. So Amazon is an extremely powerful platform for you to educate yourself for free, and have resources at your disposal for free. Best thing is, you're not paying for the power, somebody else is paying for it. Azure's got the same thing. I'm not as intimately familiar with, how they bill, but I'm sure they have a free tier. Anybody that's got Raspberry Pis, Docker runs on Raspberry Pi. And again, the feature sets are not isolated or tied to architecture. So the only exceptions sometimes are stuff on Linux versus stuff on Windows. So just caveat there. But if you want to run Docker and you want to run a swarm on Pi, knock your socks off. And then obviously Docker on Mac, Project Moby. Those are ways for us to run our containers locally on our systems. So I updated the doc here in the resources. This is a link directly to the Swarm documentation. Again, if you're not familiar with Swarm, or you're not familiar with Docker in general, I'd encourage you to check out last week's podcast. And then obviously some of the links that were in there. Again, Nigel Poulton is one of the Docker captains, and he does an amazing series on Pluralsight. Now, the conflict will be, hey, Kenny, I watched Nigel's videos and it had all this stuff about configuring, Zookeeper or console and all of those other things. That's what we're talking about in the evolution of the software, right? Is the fact that Docker saw a really key need for native clustering, native swarm capabilities. They built it directly into Docker Engine. You still have the capability of doing some stuff kind of the old school way, or using different forms of like clustering. But I think that what we're seeing is a big shift towards kind of that native swarm clustering. A lot of it's dependent upon versions and things like that. And again, that's the Pluralsight here. A lot of these Docker courses that are out there were built by Nigel, and Nigel is a fantastic resource. So Again, when we're talking about Docker captains, they're the evangelists out in the community. They're the ones that are out there saying, hey, look, this is why you want to go and virtualize your apps using Docker and using containers. And get involved. There's meetup groups. There was one in Boston last night that I wasn't able to get to. Mike Coleman's one of the other Docker captains. He was talking about how to Dockerize your traditional applications, modernizing traditional applications. He's a shameless plug. He will be at the New England VTUG. If anybody's in the Boston area or New England area, it's a big event that's up in Portland tomorrow. And stop by. But the Docker captains, you're going to learn a lot about Docker from them on Twitter, and the meetup groups. You're going to learn a lot from your peers in the industry. So again, the meetup groups are it's not super clicky. It is very much there's people there that have been working on Docker for the past 3 years. There's people that have never heard of Docker and really just want to get their feet wet with it. So you'll find everybody there and in between. So talking about what's next, again, we finished Docker 101 last week. Kind of, if you haven't seen it, go back and review it. We finished Swarm this week. There are some more detailed things that I'm going to go into with networking and overlays. So some of it will be a review from what we saw in the Docker 101, but I'm going to go a little bit deeper in terms of what we're doing with overlays and how they work, particularly around their role and place within kind of enterprise deployments. And so that'll be 2 weeks from now. And then the week after that, we're going to finish up with some Docker on Windows. I personally haven't had a chance to do much with Docker on Windows. I've traditionally been a Linux guy, so I'm kind of excited to maybe deploy some ASP apps out there and learn something new myself. So with that, just want to, I guess, open it up for any questions, any comments, any feedback. Love to hear from you guys.
So I'll kick us off with a comment. The Azure free tier you were talking about, I can comment on that. You get $200 of credit to use your first month. And then if you want any additional resources, you have to go sign up for the Visual Studio Essentials free subscription. And that gets you $20 a month for a year.
Cool. Yeah, no, that's great. I mean, if you guys are Azure guys, sign up on there, or if you're Windows guys, sign up on there. If you're already using AWS, again, the free tier is amazing.
Yeah, it's a little different, but I just wanted to make sure if anybody wanted to hear from that perspective that I said that. So I haven't seen any questions come through. I think everybody's been absorbing stuff. So if you have any questions, go ahead and raise your hand here in the attendee window. Got some comments just saying things are great, and it was really good. Deep, but not too deep dive. I know it's hard to get into the nerd knobs in an hour. So
yeah, and don't. Hopefully, this has piqued your interest. I'm happy to answer questions, on Twitter, or if you want to email, or talk after a brown bag. Find me at a local event. Any of those work to go deeper. If we serve the community, and we're community members. We're all community members. So people say, hey, look, I really want a 3-week deep dive on Swarm. We can certainly arrange that. So certainly don't be afraid to ask for more. But I think the goal here is, there's so much to Docker. It's really difficult to kind of cover everything. I think we're going to have 4 hours total. It's going to be tough to cover absolutely everything. The idea is to get you guys interested and, either make you want to learn more or have us create some more sessions for you guys.
So, Kenny, if someone wants to reach out and get a hold of you, do you want to tell them how they can get a hold of you on your Twitter handle and everything?
Yeah, let me go back through here. I guess I'll go back to the There we go. So Kanaga is my Twitter handle. Feel free to tweet me, follow me. Happy to engage with you guys. I love coming on here because everybody's super anxious to learn, and it's great that we kind of keep all of this stuff historically because I'm really interested just from kind of my own learning, and then obviously doing the presentations here. I'm always curious when a year has passed. If I come back to these presentations and I'm like, wow, man, Swarm doesn't work like that anymore, or hey, man, this has all been deprecated by this new feature. So really fast pace that everything's moving at. So yeah, feel free to reach out to me on Twitter, and if you want to go deeper on conversations, no problem with a DM on Twitter, or we can exchange emails through Twitter as well.
All right, that sounds great. Thank you very much. We look forward to the networking in 2 weeks.
Great. If anybody wants to hear anything specific, again, Twitter at Tom, Twitter at me, and or the vBrownBag, and say, hey, look, I want to know about encryption.
All right, thanks everyone for joining us for tonight's vBrownBag, and we'll see you next week.